I'm really hoping that you took a shot at size because I'm hoping, given what we've seen so far, there's plenty of there for you to build size. Um, and I'll take a shot at it in a second. But if you haven't done it yet, I want to encourage you, see what you can do. I mean, it's very similar to the number of files. It's just instead of counting them, we're counting the size of them. And I don't want you to just simply copy and paste it and make a couple changes because that robs you the experience of constructing it bit by bit as you would have to do with a brand new problem. So again, the hint I want to give you here um, is the size of something is equal to the os.path dot get size. Oops, get size. I think it's lowercase of start directory, for example. And so I'm obviously going to code more of this here in a second. And let's just make this count. I don't know why I left that one count. That didn't make any count. I'm just going to change it now. Size. I will make it plus equal here just for fun and return size. All right, so just give you this little hint. Now it's still going to return 0 here because there's no size to the start directory. It's directory. Oh yeah, probably should go through and pull out my print statements here as well. But again, if you haven't started this, then pause right now and start it. If you have started it, then obviously you got it going and probably ran into some issues, which was why you're starting again. But again, if you copied and pasted it, maybe don't delete it, but comment it out, quote, 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 before and after, and try and build it again. And then if not, we'll do it here in a second. So go ahead and pause and we'll continue on. Okay, so you're back. So I'm going to do this one again by hand because it's good practice for item in os.list directory start directory. And as you're redoing this, remind yourself, why am I doing this? Right? So I'm going to go to the start directory and I'm going to list everything that's in that directory. I'm going to go through that one item at a time. If you can't tell me that or tell yourself that, maybe not in those words. I mean, just if you don't have that meaning though behind you, then it's definitely worth exploring. And just as I said, we did before, print item like we did before. Hopefully you have it by now, but part of coding is understanding what these magic words do, right? Not just memorizing and repeating the magic words, but understanding what they do. So we probably need the full path as well. Why do we need the full path? Well, because we only have part of the name. It's like you running around searching for doctor. At a university, there's a lot of them running around. Dr. Tony, well, there's a few of them running around. Dr. Tony Lowe, there's me. I don't think there's another one around, but maybe, who knows? In the world, probably, but not the university. All right, so this is os.path.join. So what does this do? Well, it takes whatever the start directory path was, which could be very long, and it joins it with the path for the item, right? So if os.path. It's a directory. Well, you know what? Let's do it. Let's do it a little bit different. Let's do it as a file because first of all, I can show you is file is out there. Well, if it's a file, well then I want to add in the size of that file, right? So whatever the size of that file is. If it's not a file, well, it's probably a directory then. So let's add in the size of a call recursively. So this is the reason, by the way, that some programmers love recursion, because I just solve the problem that easily. Because the logic is pretty straightforward when we have a recursive data structure. That's why file systems are so brilliant. That's why they've existed, since the beginning of I don't know exactly when they came, but I mean, as long as I've known computers, the file systems have looked like this because it's just a brilliantly elegant solution for organizing data. And that's what recursion is really great about. And so I'm not sure. Oh, yeah, I got it right the first time. Not because I'm brilliant, but because I had a model to follow. You may or may not have got it to work right away. Um, Even this time, following me along, you might not have got it to work right away. Um, but that's okay. But because I think why recursion is difficult is twofold. Number one, it's so simple, it's kind of hard to see how simple it is. It's so elegant, it's hard to see, if you will, the cracks in the wall where, if you have a very smooth, perfectly round room, if you've ever been in a room like that, it's kind of disorienting. Like where does the walls end? And, it's all, big white space or whatever color it might be. And that can be true of recursion as well. It's like, well, that's just too simple. But if you understand each little bit of it, which you can do using print lines and asking for help and getting advice, then all of a sudden you can see how it falls together. And it fell together nicely, mostly because I built two things exactly like it. And then when I get to the third one, it's really, really simple. And that's where I think recursion is kind of tricky because not all recursion is exactly the same, but there's a few patterns that are very, very, very similar to each other. And if your solution falls into one of those patterns, you can, as we did here, write it really quickly, maybe even the first try. It's not very good for your ledger, but that's why adding a few print lines and running it along the way is helpful. But sometimes you might get lucky on it. And even just adding print lines along the way and then taking them out shows like, well, I was trying, I wasn't sure, but I got it working. But anyway, that's a few examples of recursion. Now, these examples may or may not help you on some of the other exercises. And so we'll probably look at some of those other exercises in class, or you can ask about them at any point. Um, but the thing that I do believe will be the same that's across them, obviously there's going to be a base case. You're going to get closer to that base case, which we do in this case by not by adding one or subtracting one, but by entering subdirectories and moving through the data structure, if you will. Um, so we don't do it that way, but we do print things out. We print out where we started, we print out what we returned, we print out intermediate values that mean something to us, like we saw in the previous examples, like we saw in all of this stream. And hopefully, you don't just print it out and say, a bunch of mess, I don't know what it means, but you can use that mess to make sense of how the program flows and where your data items flow through this. What's the input? What calls happen because of that input? Where does it loop? And where does it recurse? And I think that's really the key to understanding and making these recursion exercises work.